Hello, this is a tutorial video for creating my own drone model in PX4 based on the provided models and implementing a Leo and octomap for the exploration. So before we begin, you should have a bridge open source between the ROS and Gazebo and microXRCE agent and Q ground control and some open sources I'll be uploading in the Git. So let's begin. So first we're going to make our own customized drone model. So go to the tools, simulations, GZ, and models. And here you're going to see various provided models. And for me, I will be choosing X500 lighter down. And I add some definition, mainly the 3D lighter. So here I'm going to be basing on the X500 model. So it'll be between the include. And for the 3D lighter, I'm going to be adding some definitions by myself. And here the update rate is 10, which means the LiDAR's output rate is 10 Hertz. And you can also modify the name of the topic. So in the PX4 and Gazebo, the native topics are very long. So you can just modify it with a short name. And for the vertical samples 16, this number means that I've tried to make a VLP 16 model sensor. And lastly, you must have a joint between body, which means X500, and the LiDAR. So, and then we're gonna take a look at the base model X500. The X500 it only includes 4 plugin definitions, and it also includes some other base model X500 base. And in here, this will be the ultimate base of the model, and here is a IMU sensor definition with some errors and noises. So if you add some definitions like me in here, you're done with making your own custom model. So, and if you're trying to make some more sophisticated custom model, not basing on the existing model, you're gonna have some more complex procedure, but I'm not gonna do it this time. And let's see what. So the model is here and the words is here, and I'm gonna be using some custom model I've downloaded on the internet. So I'm gonna use this TalkBot DPaw and X500 lighter down model. So let's see. So with the PX4 directory that I'm going to build, the PX4 in simulation mode, and choose the model and the world. In here, I'm going to turn on the micro XRCE so that PX4 can communicate with the ROS2. And here, micro XRCE became the native communication method when the PX4 is turning into like ROS2 environment. So this is the default setting. So you can see the micro XRCE TDS client in the PX4, which means that XRCE agent is turned on and the ROS2 and PX4 is normally communicating. And also you're gonna need to turn on the Q ground control. So the Q ground control is required to when you're trying to fly the PX4. So I can see the ready message. I'm gonna move this to another workspace. You can see the drone here. and let's see if they can take off. So put in the command of takeoff and the drone goes arm and gonna take off. So at this time, if we list the topic list, we're gonna see some topics which stem from the PX4 who came out of the microXRCE agent, and some topics that ROS2 is giving to PX4 through the microXRCE agent. And there are no topic of the IMU or LiDAR and clock, which is in the gazebo only. So if you look at the gazebo topic list, so here is the sensors that I have defined in the models STF files. So here, the LiDAR and LiDAR points. So since I have wrote that the topic's name is LiDAR, it comes with LiDAR. And in the case of the IMU sensor, there's no like specific topic definition. So the IMU sensor's topic is very long. So let's go back and make it some more simple. So here, I'm gonna type in topic. Let's say the topic name to be IMU data and like this. Let's first look at the result.
Communication regained. Disarmed. Full flight mode. Position flight mode.
So the different thing is that we're seeing this warning message that EKF2 have failed. So the reason why this is happening is that I have not changed the topic name in the PX4 perspective. So what I have written here is the topic name at the gazebo. And the PX4, in the case of PX4, they cannot read this line. So they are provided with the IMU topic from the gazebo bridge. So let's go to the gazebo bridge directory. So here in source and modules in simulation, GC bridge in here. So here's the IMU definition. So yeah, in here, PX4 still knows that the IMU topic's name to be this long thing. So we're gonna change it with the modified one. So IMU data. So let's see again.
Communication regained. Full flight mode. Position flight mode.
So we're seeing the ready message. And if you type the gazebo topic list, you're seeing the IMU data. Before it was listed in this long name, but the long name is gone. And the IMU data. So, and next we're gonna, so from until now we have made a PX4 and gazebo and PX4 and ROS2 to communicate, but we haven't set the communication between gazebo and ROS2. We're gonna make that happen. So we're gonna make the gazebo and ROS2 to communicate. So to make that happen, we're gonna use the ROS2 and gazebo bridge. So it'll be here. I'm gonna put it on the video description. So in here, you don't need to look at this. So it is already existing open source, so you can just build and use it. So the command is like this: ROS and GC bridge, the parameter bridge, and it goes like this. You type the topic name in the gazebo first, and the topic of the ROS2, and we're gonna do, we're gonna need the point cloud 2 topic in order to look into the lighter points. And lastly, Gazebo's type, Gazebo topics type. So topic. So I'm gonna type these to look into the type. So here, yeah. Let's first try the liner only. So you can see some unknown messages error. This is the reason why is that I've not sourced this package yet. Uh, yeah, and then try again. And we're now looking at. So checking again. So after this command, we can see the lighter points available also on the ROS2. So let's do the whole part. And IMU, IMU, and the ROS2, the IMU sensors. Method type is, what was it? And the type IMU is this. And lastly, we're gonna need a clock, the time information. We can just follow this command. And everything's done. And let's into the ROS2 topic again. IMU, LiDAR, and clock. Okay. So the only thing left is to turn on the FastLeo and octomap server. So let's go. So the LiDAR, IMU, and ROS2 topics already being flowing out. So we just need to turn on. The reason why I cannot see anything here is it might be in the FastLeo repository. Let's see. Hmm, here points. So I see. So the FastLeo's Velodyne YAML is looking for the IMU topic named with IMU only, but the actual topic name is IMU data. So let's do it again. So I can see now, and we're gonna turn on the octomap. So octomap and the FastLeo ROS2 version is also included in the GitHub repo that I will be uploading in the video description. You can just download it and build it. So ROS2 launch octomap server, octomap mapping. So here you're gonna see a occupancy map. And so lastly, you're gonna use the virtual joystick. You can set it with application setting or vehicle setup. You can look it up. And let's see everything in one site. So currently the drone is on the ground. So
Data flight mode. Position flight mode.
so if you move this with the drone executes the mapping. So the camera is stock, and I'm gonna do the rest. So here, some occupancy map around some obstacles is created. So this will be the end of the tutorial, and I'm gonna come back with some autonomous exploration tutorial. So thank you.